Alrighty, good evening, everyone. This is meteorologist Timmy Albertson here with you guys for tonight's weather chat. Not really a whole lot of activity going on, and since last week we were tracking that, basically that severe weather across parts of the Midwest, I figure we'll kind of do a little bit of a follow-up today on some of the surveys that were conducted on some of those tornadoes. Now, we'll take a little bit of a look here at the radar, from Thursday evening in a few moments, but I at least want to show you where we stand right now with some of the surveyed tornadoes. Now, there are a couple of caveats, but we'll go through it here. So, for those of you who happen to like tables, well, this is going to be your moment here. Let's take a look here. All righty, everyone. So we are going to take a look here at and there were additional tornadoes that did actually occur, but outside of the area. But for right now, what we're going to focus on is the part of Indiana and Western Ohio where we saw most of that activity. So, handful of tornadoes, courtesy of basically three individual storms. Now, what's actually pretty interesting, and we did not cover this because this happened way before we started our live stream, but there were some storms that were pushing through eastern Indiana late Thursday morning into the early afternoon. One of those did actually drop an EF2 tornado at about 2 o'clock Eastern time. That went till about 2:30, and that thing was on the ground for about 18 miles, and it actually crossed the Ohio River twice. So let's talk about the whole EF scale thing here. So for those of you guys who might not be familiar with it, the way that we rate tornadoes is based on the damage that they create. This is where it gets a little weird. With hurricanes, we just look for the sustained wind. That's how we categorize it. But tornadoes are a little bit different. We use the damage to estimate the wind speeds. So if there's no damage, we can't give it a higher rating. Now, the lowest when it comes to the enhanced Fujita scale, as was with the original Fujita scale before 2007, EF0 is the weakest, and those have a minimum wind of 65 miles an hour to a maximum of 85 miles an hour. Then we go up to EF1, a little bit stronger, 86 to 110 mile per hour winds. Once we get to EF2, that's what we kind of start to consider more of a significant type of tornado. This is the one that will really start to produce some of that damage, and those have a lower bound wind of about 111 miles an hour and a maximum wind of about 135 miles an hour. To put that into perspective, for those of you who like hurricanes, that's basically somewhere between a high-end Category 2 and a low-end Category 4 hurricane. So you get kind of an idea of the damage. Once we get to EF3, now we're really talking here when it comes to strong tornadoes. And these guys have wind speeds about 136 to 165 miles an hour. So basically, if you want to think of it as a hurricane, it's a high-end category, or sorry, it's a low-end Category 4 hurricane to a low-end Category 5 hurricane. So put that into perspective for you. What about the EF4? Well, those ones are typically, well, very, very strong. They're much stronger than the EF3. They got winds of 166 to 200 miles per hour. Most tropical systems that we see in the Atlantic Ocean do not reach winds of 200 miles an hour. And then, of course, there's the biggest of them all, the EF5, and those have winds greater than 200 miles an hour. So that's at least it on paper. Now, keep in mind that we can only determine these winds if there is damage. Now, in recent years, Doppler radar has been able to kind of give us at least a little bit better of an idea sometimes with some of these storms, especially if it's on the Doppler on wheels vehicle there. But if, for example, a good example would have been the 1999 Moore, Oklahoma tornado. For those of you who don't remember that one, it had wind speeds measured on a radar about 318 miles an hour. That's pretty significant. That would easily be an EF5 tornado today. However, let's talk about the El Reno tornado. For those of you who remember that one back in 2013, it was the widest tornado on record, beating out the one in Nebraska a few years before that. Now, this 2.5 mile wide, actually, I think it was 2.6 mile wide behemoth, there was actually a measurement of winds of about 200 miles per hour. That would easily get it to be an EF5. However, the El Reno tornado happened in a primarily rural area, and the most damage that was found was that of an EF3. So it actually got downgraded not long after it was at least one of the surveys was put out. It got downgraded to an EF3, even though we assume, or based on what our measurements are, that it had winds easily of EF5 intensity. But again, there was not that much damage that could be surveyed from that thing, even though it was 2.5 miles wide. So that gives you an idea of when it comes to tornado ratings. If there's no damage, it makes it very difficult. And this is why sometimes spin up tornadoes, in a derecho or a QLCS line are pretty tricky because sometimes the straight line winds from the thunderstorm can be higher than the tornado winds. Again, typically though, at that point you're not dealing with EF4s and EF5s. You normally are just dealing with the lower end numbers there. So again, we categorize it based on that. There are some additional things. How do we survey it? We talked a little bit about that when we were doing our severe weather coverage on Thursday. But again, there is damage indicators, and then it goes out, and we got to survey everything, data point them, and sometimes it takes a while. Now, here's why it's taking a little while this time around too. If you notice, doesn't look like we have that many tornadoes. And again, right now we're just looking at the mainly the Ohio portion of the event. As mentioned, there were additional tornadoes across parts of Illinois, back into Missouri, and there was also some activity during the overnight hours preceding this. Hence, the first tornado that we have up there on the list. But uh, there's one thing that also has to be surveyed is, was it one tornado? Was it many tornadoes? And this can get a little bit trippy sometimes when it comes to surveying. And right now, kind of one of the bigger questions is, there's the possibility that two of the tornadoes here on this list might have actually been the same one. That is this EF3 that touched down in Selma, Indiana, and potentially went all the way over towards Covington, Ohio. Not Covington, Kentucky, but Covington, Ohio. Pretty long track, but sometimes we see a little bit of a drop off. And so we not only have to look at the damage, but then we have to look at its path. Did this thing lift at any point? If it lifted, then it's a new tornado. If it was on the ground the whole time, it was many. Couple of great examples of this. Recently, remember the Mayfield, Kentucky tornado? I do. I remember tracking that thing pretty much its entire life. This thing looked like it could have very well been on the ground for an insane amount of distance. However, after surveying, and a couple of days later, they determined that it actually lifted briefly, and then a second tornado touched down very briefly, lifted back up, and then touched down again. So there was technically three tornadoes, albeit technically one of them was only on the ground for a very short amount of time. But it helped to make up that very, very, very long path. Had it all been one tornado, it would have easily been the longest track tornado on record. That thing was impressive. I still have the radar scans from that thing. Another example would have been the Tri-State tornado back in 1925. Now, that bad boy there, it's pretty much, we believe nowadays that it was probably what was known as a tornado family, much like the Mayfield situation back in 2021. But uh, that one, at least at the time, was thought to have been on the ground for all that distance. But now we think that it probably wasn't. It might have lifted. It might have been a couple of tornadoes. But overall, you get the idea. So that's one of the things that is being looked into right now, is that the same one in Selma was also the same one that made it all the way down to Covington, Ohio. That's a pretty long track. And if that ends up being one tornado, it would be about 50 miles of a track. And that's pretty big when you're talking about tornadoes. Unless you're the Mayfield, Kentucky tornado, that thing was on the ground for a long time, even more than that. But typically, once you're starting to get tracks more than 20, 30 miles, that's typically pretty significant. And what's interesting, and I think this is probably the first time I've ever seen this before, but if you look at the very last tornado, it happened near Delaware, Ohio. We'll take a look at that one on the radar too. Same storm that produced the one up around West Mansfield. Again, we'll take a look at these storms here individually, but that one produced an EF1 tornado that was on the ground for 36.3 miles. and only had a maximum wind estimated about 110 miles an hour. I don't know if I've ever seen an EF1 track on the ground for 36 miles. Typically, you'd expect it to be a stronger type of tornado, and maybe it was. But again, if there's no damage, we couldn't find higher damage. Unfortunately for the tornado, it cannot, get a higher rating, even if it might have actually ended up being stronger, if that makes any sense. So that being said, there you go. We had, at least across Ohio, we had three individual storms that were the main culprit for a lot of this, well, pretty much all the tornadoes that we had from there. So let's take a look here at the radar imagery. And again, this is from Thursday night. So let's take a little bit of a look here at what happened, and we'll kind of walk it through a little bit. So our first, the first one on the list there, that EF2, that happened well before the main event here. So let's talk about that main event. What in the world was going on? Well, we had quite a few group of storms that were moving their way across central Indiana into western Ohio, and these guys decided that they were going to, produce some tornadoes. This would have been the first one right here, or yes, this would have been our first one. The one that produced that very strong tornado that we saw that video from just south of Wapakoneta. This is also the same one that went over Indian Lake, which I'm sure you might have heard on the news. This is it right here. Again, it produced a tornado just west of Salina, and then again as it made its way towards Wapakoneta. We were watching this one on the radar imagery. Very, very impressive returns on that. Again, ended up being an EF3 here. And while it might be a little bit difficult to see, this is that storm right there. Doesn't necessarily look like the strongest, but then again, folks, keep in mind we're looking a little far away from the radar site, but we'll see maybe if we can't pull up the date and radar here. But just focus on this storm. Again, made its way through Wapakoneta, Neil Armstrong's hometown there, and that trail continued on the ground as it made its way towards the place here of Lakeville, and right by it is Indian Lake, which is kind of a popular tourist attraction across west central Ohio. That trail then went through there and then continued on the ground until the town of West Mansfield, not to be confused with the regular Mansfield, which is further back over in central Ohio. All right, there it is right there, pushing its way through. You can kind of see it there on the radar imagery right there. I'm trying to point to it, but I can't. But pretty much right on the county line there of West Mansfield, you can see it right there. A little bit hard to see on this particular radar imagery, but to the trained eye, it kind of stands out a little bit there. This is then the same storm that made its way across parts of just north of Marysville and Union County, and then all the way into Delaware County, Ohio. Now, this is a very populated area. For those of you who don't know, this is Columbus. All right, so this is one of the main populated suburb areas. If you've ever been there, traffic is a nightmare, especially once you get off the interstate. So let's take a look at it here on the radar. Again, this is a very well-defined supercell thunderstorm, and you can see that hook that just kind of bulges out there just west of Delaware, and you can see how that storm kind of tracks its way through, ended up passing just north, but this thing stayed on the ground all the way towards north of Sunbury, went back into parts of northern Licking County, and then eventually it did weaken off there. So that was the one storm, and this guy produced the majority of the activity. There was a second one that happened all the way up north here. First tornado that this guy produced was actually in Hancock County, just behind it there. And then it produced that kind of long track EF2 tornado that at the time was reported to be about a half-mile wide. I think it ended up being just a little bit narrower than that. But this was it right there, kind of tracked its way, and then eventually it fell apart. And then the third one of the of our main family here was this guy that developed outside of Muncie, Indiana. Passed just north, touched down in Selma, high-end EF3 tornado went through Winchester and Union City, and they're trying to determine if this tornado might have actually continued even a little bit further beyond that. So this one is also still kind of being surveyed. And keep in mind that this one actually crossed two weather offices, so there has to be some coordination with that guy. So that was kind of more or less a little bit of a look at what had happened. And like I said, these storms were these were, your kind of your classic supercell type of thunderstorms, very potent, very strong in how they did things. And in fact, we can kind of see it here a little bit better on this little more local radar, I guess, if we wanted to go with that. But let's see if we can't maybe flip on the base velocity here, and you can kind of see it a little bit clearer what we're talking about. And again, we're going to talk maybe more about this tomorrow, but let's kind of loop this through, and you can see here, right there, there it is. See where those colors get very bright and how they're right up against each other. We've talked about this a few times, many times, as a matter of fact. That's a good indication for rotation. Well, there it is. That was the first trail just west of Salina. Another one touchdown. I mean, look at how well defined that was on the radar imagery. That was very, very impressive. And again, at that point, we kind of knew that we were dealing with a, if not maybe a strong tornado, certainly a very strong rotation within the thunderstorm that we later found out was capable of producing an EF3 tornado, which is kind of what we'd expect. And then we had that kind of redevelopment there just south of Wapakoneta, the neutron touchdown, and you can see it made its way towards Indian Lake, causing a little bit of damage there. It hit a mobile home park. That thing then continued onwards across north there of Bell Fountain over in Logan County. And then eventually it made its way into Union County. But again, that's what it looked like there. In fact, we could also see it here. What we can also see is the Selma, Indiana tornado on this radar here. So take a little bit of a look over here. You can see it kind of making its way through, and you'll notice that little notch right there. That was the other one that we were tracking too, as we went to about the 7 o'clock-ish hour or so. And that one was, we had some pictures of that one. But again, this really was the main storm of the whole event, which is ironic because the strongest tornado so far was actually the one in Selma. Not by much, but it was right at the it was pretty much right at the criteria. In fact, we'll pull up this table here one more time so you can see it, and I'll take myself off the screen here very quickly, and then we'll go ahead and kind of wrap this up a little bit. But basically, long story short, here we go. This is our EF3 from that storm that made its way south of Wapakoneta. It had estimated winds of about 155 miles an hour. All right, so that puts us kind of on the higher end of the EF3 scale. But then take a look there at the one that went through Selma. This guy, 165-mile-an-hour winds, just shy of being an EF4 tornado. But we'll see maybe if that ends up getting updated. But for right now, that's where it's looking like it's going to be sitting as a high-end EF3 tornado. The one that did go through south of Wapakoneta ended up being about a half-mile wide tornado. That was our widest tornado of the event so far. But the one that went through Selma was not far behind in terms of its width there, about 2,100 feet wide. So certainly a very interesting event that we had there. All righty. Well, I think we covered some stuff tonight. All right, well, we'll take a look tomorrow to see if we get a final answer on a couple of more of those tornadoes. As mentioned, there were some other ones. We'll try maybe taking a little bit of a look at a map so we can see those tracks a little bit more individually. But for right now, given that the fact that they're still somewhat being surveyed, we'll just wait, see it tomorrow, and maybe we'll see if we have some of the final tracks, at least for right now, on some of those tornadoes. So, that in mind, thank you all very much for taking the time to join me on tonight's weather chat. We'll see you back here tomorrow evening. Until that time, keep enjoying that weather.